Hey guys, just before we get into the lesson, I just want to let you know that you can catch these live on YouTube every Tuesday from 6 PM till 7 PM in the UK time. And that means you can be more interactive, you can ask your questions and they'll be answered. Okay, so without further ado, let's get into the lesson. So welcome everyone to another one of the GCSE exam lessons, tuition lessons. So today we're going to go through some circle geometry, so literally everything to do with circles. I'm very well, thank you. So what I did for this lesson is I went back through the last few years and I gathered every single question related to circles that I could find. So that will allow us to get basically the maximum amount of exam practice. So the reason why I wanted to go through circles is A, it was requested, and B, that it comes up roughly 3 or 4 times every year. Hello Lila. So just so you're aware, there's normally at least one question in paper 1 and one question in paper 3. So on average, there was 3 or 4 questions each year. So like it might be 2 in paper 1 and 1 in paper 3, or 1 in paper 1 and 2 in paper 3. So some of these are non-calculator, and I've labelled them with non-calculator. But yeah, it comes up extremely frequently. So that's what we're going to be doing today. So we've gone through circle theorems, we've gone through some of the geometry stuff. The only thing I haven't gone through is the equation of a circle. So I want to go through that really quickly, and then we'll get straight into the questions. So the equation of a circle for GCSE is quite simple. It's just x squared plus y squared, and it will always equal some number. That number is r squared, where r is just the radius. Nice and easy, okay? So for example, if they gave you an equation of a circle that looked like this, then what you could say is that the radius is the square root of 9, which is 3. So normally we would have plus or minus 3, but if you think about what we're talking about, a radius can't be negative, so we just stick with the positive value. That's the only thing we haven't gone through yet, so we're going to get straight into the exam practice. And again, these are all actual exam questions gotten from the last few years. So I went back to up to 2019 because I just had too many questions to do otherwise. So let's get started. So this is the first one, fairly interesting question. So we have A, B and C are 3 points on a circle. The radii from A, B and C are shown. So again, you may have done these already in your mocks or as practice. And it says, is AC a diameter of the circle? So one thing I will say is that we know that these lines are all the radius. Okay? So the definition of a diameter, and again you need to know the definitions of different parts of a circle, is it's a straight line that goes through the middle of a circle. Okay, that's it. So I know for a fact AC goes through the middle because it's the radius. Okay, the thing I don't know is if it's a straight line. Okay, so I know it goes through the middle. I just don't know if it's straight. So how can I tell if it's straight? Well, if I calculate what this angle is here, the 5x plus 40, angles on a straight line should add up to 180. So if this angle here is 180 degrees, then it is a straight line, so it is a diameter. Does that logic make sense? Whilst you think of that, I'm just going to start doing it. So to work out the value of x, all we're going to do is add all of the angles together, which is a bit tedious. Now, what we have here is angles around a point, right? And they should add up to 360. Okay. So if we just start going, so x plus 4x plus 40 plus 5x plus 40 equals 360. Add all the x's together, we have 4x plus x is 5x plus 5x is 10x plus 80 is 360 minus 80 from both sides, which should give me 280, and so x must equal 28 degrees. So all I need to do now, there's actually 2 ways, right? If I work out the value of this angle and it's 180, that's good. Or I can work out the value of this angle here, so x plus that. This one just looks easier, that's why I chose it. Okay? So 5, open bracket 28, plus, what was it plus? 40, And again, this is a calculator question, so if you want to be a bit lazy, we're more than free to use a calculator. So we have 5, open bracket, 28, plus 40, 180. Therefore, AC is a diameter. So it's not just because it's a straight line that it's a diameter, right? Like, for example, if I drew a line that was down here, that's a straight line, but it's a chord. So it's specifically because it's a straight line that goes through the center. How do I know it's through the center? Because all of these lines are the radius, and the radius has to be from the center of the circle. 3 marks, not too bad, but it is a bit of a different style question, so it can easily throw people off. I hope that's all okay. Straight to the next one. This is a 1 marker, so multiple choice with the AQA exam board. So work out the length of the diameter. Well, if you remember what I said earlier, x squared plus y squared is equal to r squared. So the radius in this case is square root 11. And what's the diameter? The diameter is twice the radius, so it's going to be 2 square root 11. Okay. So this is a 1 marker they like to ask in paper 1. So this is actually technically a non-calculator paper question, but you don't really need a calculator for it. So far so good? Perfect. I think we're pretty good. Yeah. Okay, so this is where things get a bit more interesting, right? When we have this weird looking spaceship design. So, A, B and C are points on the circumference. Cool. B, D and C, D are tangents to the circle. A, B, C, D is a kite. Honestly, the A, B, C, D is a kite thing, not really relevant. But if you remember with a kite, A, B, C, D, it means that this is going to be a symmetrical design, right? So the angle at B is the same as the angle at C and so on. Not super relevant, but still, it's X. So we need to use a few circle theorems to do this proof. Now, what I will say is that prove that angle ABO is this. The angle ABO is this angle here. Okay? However, it's this kind of triangle here that we're referring to, okay? I'm going to remove that line just for now because I think it'll be easier to explain, but that's what we're looking for, right? So, we need to think of a few circle theorems. The first one is that if you have a tangent and a radius, they meet at 90 degrees. Okay? So that's a circle theorem. If you want me to write down the circle theorems, like actually let's write it down, right? So tangents meet radius at right angles or 90 degrees. Okay? That's just one of the circle theorems. So I can work out what this is. Now you might be thinking, why am I doing this? So what I'm trying to do with these exam questions is go through my way of thinking, and that might help you understand what to do. So once I have these 90 degrees, I'm kind of stuck, right? However, I'm thinking of another circle theorem. Okay? This angle here is going to be half of this angle here. So again, angles at circumference are half that at the center. Again, please stop me if any of this doesn't make sense, okay? So if I work out what this inside angle is, well, this is a four-sided shape, right? So the angle should add up to 360. So in other words, that angle at O, so I'm going to call it angle BOC, should equal 360 minus 90 minus 90 minus x. So in other words, it equals 180 minus x. So I'm going to stop for a second. Is that all okay? So again, this is a four-sided shape. Four-sided shapes always add up to 360 in terms of their angles. Okay? Good to hear. Okay. So I'm going to clear this up a bit just by getting rid of some of these lines. Okay? So I know that this angle here is 180 minus x. Now, the angle behind it, this one over here at A, is half of that because of reason number 2. Angles at the circumference are half that at the centre, right? Because they're made from the same 2 points on the circumference. So in other words, the angle, I'm going to call it CAB, cab, is half of that. So it's 180 minus x. So in other words, it's going to be 90 minus x over 2. Now if you notice, I'm actually really close to the answer already, right? The answer is just half of what I've already got. Let's think about why. Well, if I draw a line straight through this, okay, this angle is the same as this angle because it's an isosceles triangle. Okay, so if I clear this up a little bit, let me just delete some of the lines just to make it super clear. If I clear this up a bit, these lines here are both the radius. So it's an isosceles triangle, so the angle at B is going to be the same as this angle, right? And this angle is half of this. So OAB is half of that. It's 45 minus x over 4. For those of you that have just joined, feel free to ask me to go through the question one more time. I'm going to go through it anyway, just to recap. And OAB is the same as ABO because it's an isosceles triangle. Yeah. Therefore, it's right. 4 marks. So, quick recap. We started off trying to find out what angle BOC was, which was this angle over here. And the way I did that is I know that these two are right angles because of reason number 1. Tangents meet radiuses or radii at 90 degrees. So this angle here is going to be 360 because angles in a quadrilateral add up to 360, minus the 2 right angles minus x. Okay? The next thing I did is I know that this whole angle here at A is half the one at the centre because of reason number 2, circle theorem number 2. Angles at circumference are half that at the centre. Cool? And that gave me 90 minus x over 2. And again, I'm looking at the answer. The answer is just half what I've got already. It's pretty good. Now, I want this angle here. If I draw a line through this, that is an isosceles triangle because all of these sides are radii. So those 2 angles are the same as each other, and I split this one in half because it's a kite. So it's symmetrical. I've split it in half. So it's 45 minus x over 4. And both the angles are the same, so the other one's 45 minus x over 4 as well. Cool. So again, a few people just joined. I hope that summary was pretty good. We're going to go on to the next ones now, unless anyone has any questions. 3, 2, 1. Okay. So again, there is a bit of latency. Okay. Now, you're very welcome, hydrocarbon. No worries. That's fine. Again, I want this to be as useful as possible to as many people as possible. So, now this one I've labelled as non-calculator. So we have 2 wires. This one is a bit tricky. Not too bad though. 2 wires, 2 wire shapes make an earring. The shapes are a full circle with radius 21 millimeters. So and a quarter circle. Okay? And it says show that the radius of the quarter circle is 6 millimeters, and they tell you that the radius of the circle to the radius of the quarter circle is 7 to 2. So if you remember, the radius of the circle, if I change that ratio into a fraction, is going to be 7, right? Because that's the side we're looking at. Thank you very much. Is 7 because that's the side we're talking about, right? 7 over 7 plus 2, 9, right? That's just how I change a ratio into a fraction. Okay? And 7/9 is equal to 21, right? Because that's what the radius is. And the radius of the quarter circle, I'm just going to write it in a bit of a short form. Honestly, I don't think that was any shorter. Is going to be 2/9. And what does that equal? Well, if 7/9 is 21, then 1/9 is 21 divided by 7, which is 3. So 2/9 is going to be 3 times 2 is going to be 6. Which is exactly what they're asking me to do. Hope that's all okay. Again, bit of a synoptic question. They added in a few different topics, but hopefully not too bad. Okay, so that's not too bad, hopefully, okay? Now with part B, this is where it gets a bit more interesting. So I'm actually going to move this question up so we can see it. Work out the total length of the wire in the earring. And again, this is a non-calculator paper. Give your answer in the form A pi plus B. Okay, so this line is wire, and this line here is wire, right? Now, the total amount of wire in this ring is just going to be the circumference of the circle. Now, the circumference of a circle, hopefully you already know, is 2 pi r. So, 2 pi times 21, which is just 42 pi. Not too bad, right? So that's the circle done. That was the easy bit. Now this second part, so I read through the kind of examiner's reports as well, but also from my own experience, or pi d exactly, is this second bit always catches people out because there is a hidden thing you need to do. Okay? So, if I want to work out this, what some people do, and this isn't wrong, is this is a quarter circle. So the circumference of a quarter circle is just going to be a quarter of a full circle. And that's true. Completely valid. But they forget you need to add these two sides as well. If you take a quarter of this, it will only give you the curved bit, the arc perimeter. Okay? So you need to add on those two things, which are 6 and 6. So the full length is going to be, not an equal sign, it's going to be plus 6 and another 6. Okay? So that is where most students lost their marks. Okay? So try not to make that mistake. So the radius here is going to be a quarter times 2 pi 6 and then plus 12 afterwards. So what I'm going to do here is I'm going to do 2 times 6 is 12 and a quarter of 12 is 3. Yes. So 3 pi plus 12. So now the total is the 42 pi we had from the first bit, the big part of the earring, plus 3 pi plus 12. So it's going to be 45 pi plus 12. So A is 45, B is 12. They're both integers, so it looks like we are correct. Okay. And again, so for those of you that have joined, please feel free to message as soon as you find that something's wrong. Treat this like an actual tuition lesson. So ask me questions, challenge me. If I've done something you think is wrong, let me know, and so on. But is that all okay? So some of these were a bit tricky, a bit more interesting, right? So again, just for those of you that have joined, the reason why I've done this is A, it was requested, so please feel free to request topics during the lesson. But also, when I was going through the papers, this came up. There was roughly 3 or 4 questions per year. So all of these questions are only 2021, 2020 and 2019. And you'll find that there's actually a lot of them, okay? So 3 or 4 questions a year, so it's really important that you're good at this. And scroll down. This is not a non-calculator, so we can use a calculator. Okay, and this again comes up with a circle theorem. So although there's no circles, cyclic effectively means circle in this context, okay? Prove that ABCD is not a cyclic quadrilateral. So what's a cyclic quadrilateral? Well, if I draw a circle or a potato, a cyclic quadrilateral has all of its points on the circumference of a circle. And the opposite angles add up to 180. Well done, Lila. Perfect. Okay, so if I label up all these angles, A, B, C, D. So there are two ways to tell if something's a cyclic quadrilateral. One, are all of the points on the circumference of a circle. They haven't shown me the circle, so I don't know. Two, if it's a cyclic quadrilateral, then the opposite angles add up to 180 degrees. So the problem with that, and I get the circle is confusing, the problem with that is every quadrilateral adds up to 360. So we can't use that. So specifically, it's the opposite angles need to add up to 180. Okay, so how can I work this out? So what I need to do is I need to work out what x is first, right? So I need to add all of these together and equal it to 360 because every quadrilateral adds up to 360 degrees. Okay, so we have 4x plus x plus 36 plus 92. Not all of them hydrocarbon. I think it's just the person that's YouTube team. They mentioned that they're in A levels at the moment. Everyone else, as far as I know, is actually in GCSE. So yeah, this is a GCSE lesson, I promise. So now we collect the like terms. 4x plus x, 5x plus 10x, 5x again gives me 10x. Let's be nice and lazy and use a calculator because it's not a non-calculator. 36 plus 92 plus 30, 158. Subtract 158 from both sides, and that would give me 202 degrees. So then x is equal to 20.2 degrees. Let's just double check to make sure I've done everything right. Okay. Yeah, should be fine. Yeah, that's fine. Okay, cool. So, prove that it's not a cyclic quadrilateral. All we need to do is pick one of the sets of opposite angles and see if they add up to 180. So let's pick A and C. So 4 times 20. I can already see this won't add up to 180. Right? That's going to give me 80.8 plus 92, which would be 172.8 degrees, which is not equal to 180 degrees. So it's not a cyclic quadrilateral. Yeah, so YouTube team, so I normally just accept the questions myself. So don't worry about that. I appreciate the offer though. Okay, so again, my email address is actually in the description of this if you do want to send me anything or do anything like that. There is actually something I want to speak to you guys about at the end of the lesson. It's not related to this GCSE content, but it is something that might interest you. So stick around for that. I won't do it in the middle of the lesson just so we stay on topic. But yeah, there is something interesting I'm thinking of doing. Okay, so yeah, it's not equal to 180 degrees, so it's not a cyclic quadrilateral. Okay. Okay. Absolutely, yeah. So as soon as I finish my announcement, we can go through one of your questions. That's totally fine. Yeah. So, hopefully that was okay for the previous one. And so YouTube team, if you wait to the end, I will see if I can help you out with that, okay? Or if you send me an email, that's also something I can do, because then I can send you links and stuff. Okay, so let's read this question. So A and B are points on a circle. PA and PB are tangents. Work out the size of angle APB. So just so you know, that's going to be this angle here. Now this looks pretty bare bones at the moment, right? AB is not the diameter, well done. And we know that because this angle's not 90 degrees, right? So it doesn't meet at the radius, which means this isn't a diameter. It's a chord. Good. So what can we do? Well, there is yet another circle theorem. Okay? Tangents from the same point have the same length. Oh. So in other words, these two are the same length. So tangents, good question, yeah. Tangents are lines that touch a circle only once. Okay? So they meet a circle, they touch it at one point, and then they go off and never touch it again. So these kind of straight lines here, from P to B and A to P, can you see they only touch it once, and if we were to continue them, they would never touch them again. Okay. So, now that I've drawn these lines, hopefully you can see that this is just a big isosceles triangle, which means the base angles are the same. Yeah, your arm touching someone, yeah. Right? So it's a straight line that touches a circle only once, right? So if they were to go through the circle, then they wouldn't be tangents anymore. But yeah, so these two angles are the same, they're both 71 degrees. And therefore we can easily work out what the angle at P is, right? 180 minus 71 minus 71, which is 180 minus 142 equals 38 degrees. So again, they really like to test you. That's correct, hydrocarbon, perfect. Okay, so they really like to test your knowledge of applying different circle theorems to different situations, right? And we've used ratios as well, and we've used all sorts of different things. So knowing the circle theorems inside and out is good, but practicing different scenarios is also good. So I know at least at the school I teach at, a lot of the homework that you guys get, it's very similar questions, right? That's why I really encourage you to keep doing exam questions, because exam questions are different to the normal questions that you might get. Okay? It's good to do the normal questions so you get to know the circle theorems, but this is what they're really like, and it can throw you off a bit. That was part A. So part B, this is another interesting question. So again, let's have a look. So C, D and E are points on a different circle, so C, D, E, perfect. Is X the centre of the circle? Okay. Perfect. So, if X is the centre of the circle, then I can use one of my circle theorems. Angles at the centre are twice the angle at the circumference, right? So we've used this already once in the lesson. And again, since we have some new faces today, just to go through that, this only applies when the angles are made from the same points on the circumference. So can you see that the angle X and the angle 78 are both made up from lines from C and D, okay? So that's why we can apply this. So if this angle is at the centre, then it should be twice 78. Well, let's have a look. This angle here, X, is going to be 360 minus 204, right? Because angles around a centre add up to 360, and that will give me 156 degrees. Yeah, cool. Now, 78 times by 2 equals, I mean angle E, yeah, exactly, hydrocarbon, yeah. 78 times by 2 is 156 degrees. So this circle theorem holds true Thank you, YouTube team. Yeah. So because this circle theorem holds true, this must be a centre, because it would only hold true if it's an angle at the centre. So in other words, it's yes. This is my 4. Yeah. Okay. So far so good, I think. So before we go on, yeah, everyone's great, okay. No, so hydrocarbon, so yeah. The angle at the centre is not 204. It's always going to be facing away, right? Because it's the angle made from the 2 points on the circumference. So yeah, it's actually the opposite side, yeah. Not 204, it's the 156. Yeah. Thank you for asking. It's really good that you did that. I didn't explain that fully. That's my bad. Okay. No problem. That's what I'm here for. So again, equation of a circle. Let's write it out one more time just so you remember it. And if you guys do A-level maths, as in the future you do A-level maths, equations of circles come back. So it's really good if you're going to do it then to just learn it now. I realise I wrote the same thing again. E equals r squared. So that means r in this case is equal to 3. Okay. And the diameter is going to be 2 times 3, which is 6. So yeah, there are some good pictures on Google. I also have a video that I did a while back doing the circle theorems. Either way is completely fine. Now this is a 5 marker. It's a big question, okay? Very big. They love to go through kind of the total areas of shapes, like composite shapes. So a composite shape is where you have two normal shapes and you glue them together. So this is a triangle and a semicircle, right? Lila, yes, well done. That is perfect. You're going to use the cosine rule at some point. However, not just yet. Not just yet. So if we want to work out the total area of the shape, we have two shapes, right? We have shape number 1 and we have shape number 2. Shape number 1, you've made you... Good. I'm glad. Hopefully it doesn't torture you for too long. You don't just remember it in like 10 years when you're working or something. But yeah. Now, how do I work out the area of a triangle? It's half AB sine C. Perfect. It's not half base times height, because this is not a right angle triangle, okay? Right, and in fact, what would the height be in this case? We don't have a height, right? So be careful with that. So in this case, it's half AB sine C. So you might be wondering, what on earth is A, B, and C? Well, A and B are two sides, and C is the angle between them, okay? So if you want to work out the area of any triangle, you need two sides and the angle between them. That's it. So it doesn't matter what you call each one, right? You just need two sides and the angle between them. So if I just sub in what I know, it's a half. A is 8. B is 10. Sine 114. I don't know sine 114 off the top of my head, so again, this is a calculator question. So we have 0.5, which is a half, times, 8 times 10 sine 114. Also, if anything's not big enough, like you want me to zoom into anything, please let me know. We get 36.54. I'm going to keep it to 2 decimal places just until the end so we can get an accurate answer. And that is centimetre squared. Again, remember units. If you forget the units on your final answer, you lose a mark. So you can only get 4, which sucks. Cool. So now, we've got the triangle and that's good. We now need to work out shape 2, and that's the hard bit. It's a semicircle, right? So, the area of a circle is pi r squared. If it's half of a circle, so a semicircle, all we do is divide it by 2 because it's just a circle that's in half. I don't know what the radius is yet, but Lila, you've already mentioned this before. We can work out the length AC using the cosine rule, and that is the diameter of the circle. So if I work out the diameter, the radius is just half that. Okay? Is that all okay with everyone? I think that is. So again, Lila, I know you know. Okay. Now, Cosine rule, again, it's one of those long formulas. A squared equals b squared plus c squared minus 2bc. Also, it should, I feel like I should warn you guys in advance. Whatever exam board you're doing, there is no guarantee you're going to get a formula sheet in your exam. Okay? Last year, they gave everyone a formula sheet because of COVID and missed learning and all of that stuff. But they explicitly, so I did some training today, and the exam boards literally said explicitly there is no guarantee that anyone will get a formula sheet. Okay, so for your revision, learn every formula because you might not get one. Exactly, they're finalising it in January. So for now, assume no formula sheet. Okay? So it has changed relatively recently. So when they did the new spec, you did get a few formulas, but then they wanted to stop doing it, but then COVID happened, so they gave you formula sheets, but now they've explicitly said to us, you have to assume no formula sheet. Okay, and they're going to finalise it soon, again maybe January, as Lila said. But this is for all exam boards, it doesn't matter what exam board you're doing, none of the, again, so the fact that they explicitly say, we never said we're definitely giving one, makes me worry, okay? So just keep that in mind. You might not get any formulas at all. So, keep that in mind. Again, by the time of your exam, you're going to know all of the formulas anyway, right? And what I will say, yes, that's correct, hydrocarbon, perfect. Or you can just divide it by 2 in the first place. So yeah, getting back to where we're going, I'm going to call this side, this is my A, right? Which means this is now my capital A, okay? The reason for this is the side you're working out, you have to know what the opposite angle is. That's all, okay? So A squared equals, and then it doesn't matter which way around you put these guys because you're just adding them or timesing them, so it doesn't really make a difference. Cos 114. So then I'm going to just put this all in and then we square root it. Easy peasy lemon squeezy. We have 8 squared. I didn't use brackets. Oh, that's not good of me. It's just very annoying doing this on a keyboard as opposed to having it in my hand, but here's what it is. And square root answer. 15.14 I'm going to call it for now. Again, just to make sure we get a relatively good answer. So you can see why it's a 5 marker. So now we can work out, so first of all, the radius is half this. Okay, so I'm going to divide that by 2. 7.57. And now we can finally work out the area. So pi times 7.57 squared over 2 equals, so now we can sub this all in. So we have shift pi. I'm going to put answer button. The answer button, the ANS button, just saves whatever your last answer was, which would be 7.566, etc. So it just means you get a perfect answer. 89.96. So the total area, finally, and I'm going to do this to 3 significant figures, because that's what you normally should do it as. 36.54 plus 89.96. Again, so just add 36.54. Okay. 126.5, let's call it. That's it. Whew. 5 marker. You had to use all sorts of stuff. You had to use the area of a triangle, you had to use cosine rule, you had to use just everything. So honestly, it's a good question in a sense, but it's also kind of sucky. Okay. This is a non-calculator arc length of a semicircle of radius 6 meters. So again, a semicircle is half a circle. So a full circle would have a perimeter of 2 pi r. But because we are looking at a semicircle, we divide that by 2. So slash slash, it's just pi times 6, which is 6 pi. Not too bad, hopefully. We're making really good time, actually. There's a lot of questions we're getting through. And again, a non-calculator one. So this is quite interesting to me, because they tend to make these calculator questions, but you know. And it looks a bit complicated, right? Like they've got a semicircle inside a circle. But it's not actually that bad, okay? So first of all, we have a shaded bit inside a unshaded bit. And we need to work out how many times bigger is the unshaded area than the shaded area. So we need two values, right? We need to work out the unshaded area and the shaded area. Okay, so that's my thinking through this question. From looking at this, the unshaded one's a bit easier. You can to work out the total area, but keep in mind that the unshaded area, you have to take away the area of this bit, right? Because it's inside the shape. So this actually isn't a circle, the unshaded area. It's a circle minus a semicircle. So be careful there. But yeah, you can use scale factors, but... So shaded area is... Yeah, you can do it though. You are 100% right. It's just not great. It's going to be half of the area of a circle, half pi r squared. R is going to be 4, not 8. So what we have is we have a half times pi 4 squared. So that is a half pi times 16. So in other words, it's 8 pi. Now the unshaded, this is where things get a bit more interesting, is a big circle, which is pi r squared, minus 8 pi. So again, one of the problems with this question that I can foresee is people just working out the unshaded area as a circle, which you will still get some marks, but you won't get all of them. So we have pi times 10 squared minus 8 pi. So that is 100 pi minus 8 pi, which is, equals 92 pi. Now it says, how many times bigger is the unshaded area than the shaded area? To work this out, I can take the unshaded area and divide it by the shaded area to work out how many times it would fit in. And if you notice, the pi's cancel out. Yeah. So we can just keep simplifying this or do whatever you want. So if we keep halving it, that's what I prefer to do, 46 over 4. 92 isn't in the 8 times table, that's why I'm doing it in a bit of a different way. Then we have 23 over 2. 23 over 2 is 11.5 times bigger. Whew. 4 marks. Not a bad question, I suppose. I think that's pretty good. There is actually also another thing I'd like to show you at the end of this lesson. So I've got two things, I guess. Essentially, yeah, it's not too bad. Again, the tricky bit is this minus 8 pi. Because, okay, I do the same thing, by the way, even now after teaching maths for a while, is I sometimes get a bit excited in the questions and I rush it, and I could see myself forgetting the minus 8 pi sometimes. I admit it. Again, just when you're in an exam, it's very tempting to do it quickly. Just really think, okay? Because that minus 8 pi, I guarantee you lost people marks. Oh, I'm glad you did hydrocarbon, perfect. But just so you know, when I did my training today, the exam boards basically re-released the exact breakdown of what kind of topics can come up, in the sense of, you know how you have 6 major topics and everything. So if you're interested, I can make like a short video and upload it that will go through exactly what the assessment objectives are, so what they mean by that, and the exact breakdown of how much of each topic can come up. If you're interested in that, I do have that information, I can make it, yeah. And it's the same for all exam boards, by the way. That's one thing that you should know, is all exam boards have to adhere to the same rules. So it doesn't matter what exam board you're doing, okay? There are 6 topics that come up. And these are major topics, right? Like numbers, algebra, ratios, statistics, probability, and geometry. Those are the 6 main areas. But yeah, I'll make a video on that. I'll get it out tomorrow. I can do it for A-level. The only tricky thing is it depends on exam board. GCSEs are standardised, A-levels aren't. Which bothers me to no end. But yeah, I will do that for... I'll definitely do it for GCSE. I'll try and get it out tomorrow, if I can. But I'm working quite late tomorrow. Anyways, enough about me. This is another circle geometry question, kinda. Okay? It combines circles and equations of lines, so I thought it was quite interesting. So it's non-calculator, as I wrote in big letters. So we have a point here, it's a tangent to the circle. So, funnily enough, these questions used to be 6 markers in total. They didn't break it up into 2 parts. And they were really hard. So what they did to try and make your life a bit easier is break it up into parts, okay? But yeah, before it used to just be one big 6 marker. So I'm really happy they made this change, because I think it's a bit unreasonable just to throw you into the deep end. I'm glad you liked them, Evie, so you already know the trick. So show that the gradient of the tangent is -1/2. So I know what you're probably thinking. We only have one coordinate, we can't really work it out. Do I know the shortcut? Well, how about I do it my way and you can tell me if you know if it's different to what you're thinking, Evie, yeah? But you probably know it already. You guys know it. So what we're going to do is, this is the radius. It meets at 90 degrees, which means they're perpendicular. And again, that's just one of our circle theorems. Tangents meet radii at right angles. So, yeah, sure. So a tangent, again, it tells us it's a tangent, right? It's just a line that meets a circle at one point only. Okay? That is called the reciprocal. Well done, Lila. So a gradient just tells me how steep a line is. So it's good that you don't know because we can go through it. So the coordinates of this center point is just 0, 0, right? Because it's the origin. Now the gradient, which I'm going to represent here, is just the change in y over the change in x. And please excuse my horrible straight line there. So, if I look at these 2 coordinates here, right? The y coordinate is 8 here and it's 0 here. So the difference in those numbers is 8 minus 0. Hey Nathan, how are you? Yeah, so OneNote is a bit bad because there is a straight line feature. The problem is the line's really jumpy. So it only has certain things. And yeah, the x-coordinate starts at 0 and ends at 4. So the difference in that is 4 minus 0. Okay. So just so you know, Nathan, by the way, immediately after this lesson, when I end it, you can go back and have a look. We've done every single circle-related question, so anything with circles in it, for the last few years. As preparation, there's been some really good questions. If you want to go back and look at it, you're more than welcome to. Or even go back now. I think you can do that on YouTube. You've got a better shortcut. Okay, Evie, can you tell me what it is afterwards then? 8 over 4 is 2. Now, if 2 lines are perpendicular, I actually don't know what the shortcut is either, hydrocarbon. I'm actually interested to find out. So, if 2 lines are perpendicular... Oh, do you just do 8 divided by 4? Anyway, no, don't tell me. We'll do it in a second, I promise. If they're perpendicular, then that means the gradient of the tangent is just minus 1 over the gradient. It's the negative reciprocal.